want to jump anyway. You can take notes. Hopefully you learn, back in the day, I would be like, okay, if you do well in your first exam, I'll give you the chance to bring notes to the final. But at this point, I'm like, you're all adults, right? So if you want to mess around and fail your final, it's your choice, right? If you just want to rely on your notes and think that you can pass with them, so try it, and we'll see. It's not going to happen. If you study, then they might help. What is fun is that you bring your notes because you say you don't want to worry about syntax. So you want to, in case you don't know syntax, you can go there, right? But when I grade your exams, I see a bunch of mistakes in the syntax. So what is it really helping you? Right?
Security. You're there, thank you.
I'm never asking something from there. I'm always asking things that are different.
I know.
But what? Okay, today we're going to learn cues. So the last topic is filas colas, right? Tags and cues. That sounds weird in Spanish, right? Filas and colas, yeah.
Oh, April 9th.
Today?
Yeah, April 9th.
Yeah, tags, tags are called filas. Filar, put them, like English is also similar, right? Pile them, right?
Oh, like a piler.
Right? Similar, right? A pile of papers, right? Stack of papers, same thing, right?
Yep.
And then colas, I don't know where that's coming from. Cues, no, like colas. Okay.
So there's a cue in the tank.
Yeah, cola is like a line, but can we get a tail also? But anyway. So, okay. So, cues refer to, like he's saying, the lines that you make, for example, at the bank when you want to pay your credit card or whatever, or the supermarket. So if you remember stacks here, what we just did was called a LIFO. Last in was the first out, right? Queues are considered FIFOs. Because in a queue, the guy that arrived first to the queue should be the one that should be serviced first, right? Like when you go to, say, the drive-through, and your car is parked on the front, then you should be first than faster or before the guy that is parked behind you, right? You're at the bank, you're making the line, the teller should service you first if there is somebody behind you, right? Correct? That's the idea, right? Correct? So, that's the rule. For stacks, they are LIFOs, and for queues, it's FIFOs. So we have to respect that. Okay? Now, how can we represent a queue? Again, a queue has to be a collection of elements, right? We used an array for stacks. What could we use for queues? Anything. An array, a linked list, an array list. Which one do you think we're going to use? An array again. Why? Because we want to simulate a queue that is finite. Because in reality, all queues have a capacity, even the Black Friday queues, right? All of them are meant to have a capacity, right? You cannot put more than the capacity of the place, for example, right? Correct? You're at the bank, and there is only so many people that can be in line, right? Correct? So we're going to make our queues with an array to simulate a finite size collection. Now, if it has capacity 5, that doesn't necessarily mean that we have 5 elements, right? I could have inserted maybe here 9, maybe 7. So I need again size. Correct? What else do I need? This guy is 9, this guy is 7. If I say, remember we have push and pop in stacks to insert and remove? Here we have something called NQ to insert and DQ to remove. So this guy is equivalent to push, this guy is equivalent to pop. Queues versus stacks. Okay? Remember guys, you're going to college, you're going to university. You have to speak the right slang. You tell me I have a queue and I'm going to push elements, you sound really bad. You're laughing, but that's true. I'll tell you a story later because I don't have time about that. How I make fun of somebody. Okay? Going back to this. If I have an array like this and I have these two elements, this guy is my current front. So if somebody tells me DQ, I should take this element out. Right? Correct? But what happens when I take this element out? And somebody tells me DQ again. I should move here. This should be my next guy to remove, right? So I have two options. Okay? One option is to don't worry about a variable front. I'm putting front to indicate which one is at the front now, right? One option could be don't worry about front. Always the one at position 0 will be the one that you have to service first. So what would that mean? That if I says the Q, I will have to remove the element at position 0. So if somebody tells me the Q and I take 9 out, that means I will have to shift everything. Shifting is very expensive. If it were a linked list, it's very cheap. You just do head equal head that next. Done. Right? Correct? But in an array, we have to create a loop and keep transferring element by element. Right? How much time does that take? Forever. Right? So what we're going to do is, instead of doing that, because this is a small stack, but if the stack had 1 million elements, and you service the first guy, you have to make 999, right? 999,000 moves. Too much time. So what we're going to do is not do that. We're going to keep track of who's at the front. The first time is going to be here. Then if we DQ, we're going to move from here. So as we DQ, we move the front. Sounds easy? Sounds simple, right? And if we enqueue, do we have to change the front if we enqueue? No, because it's going at the end, right? It's going afterwards, right? Correct? Remember, there's something I ask sometimes in the exam, just to give you a heads up, because now it clicked on my head. I told you how to implement a queue in a stack with an array, right? In the exam, I could tell you implement the push, the pop, everything from the stack, but now using a linked list. Fair enough, right? I told you how to use the linked list, right? And I just told you, how would you do the queue in a linked list with queues? Would be simple, head equal head that get next, and then you return the, you have n equal head that get data, head equal head that get next, return n. Done. Simple. Right? Got it? You're updating the head. And you can check if linked list is empty, you have the method is empty too, right? With the stacks, how would you do a push? At last, and you always, or at first, yeah. Always you put it on the first, and then return the head when you want to pop. Got it? Clear? Do you understand what I'm saying? Yes, Carl.
I know that you're keeping track of the size, with the variable size, but let's say you have like, you start filling it up, and you get to the capacity, and you start doing DQ, and then you want to add
We're
some.
going to have problems there. We're going to see them in a second. You're all right. You're going to get full on one side, but there's space on the other side, right?
Right.
You're seeing the front. That's what makes queues more complex than a stack. But that's okay. You're smart guys. You will survive. So we're going to keep track of front, right? Who's on the front? And this guy pretty much indicates the index of who should be serviced. Right? No. Correct? Who's at the front, right? Who should be serviced first, right? Then we need also a size. And then we need what else? The array itself. Right? Say Q. Constructor. What else am I missing? Yes, professor, capacity. Thank you. Right?
I thought size was capacity.
So all I need to receive is capacity, right? So, well, actually I should have used otherwise I will be forced to use these, remember? Okay? You right? Size initially 0, right? What am I missing? Front, right? What should I put front with?
Equal size.
Front equal what?
To the cube? To the cube?
What should front be the first time? Maybe that's when the queue is empty.
The capacity.
Hmm?
The capacity?
The cube goes to capacity already?
Remember, if you say 0, that means that there's one element in you get a point.
Oh, Jesus. And that's needed.
So got it? So public boolean is empty. You can do it two ways. Check if the front is negative or if the size is 0, right? Let's keep it like we had it before. Public void empty. Well, you have to validate that the queue is not full, right? So you can say size is less than capacity, then you can do something, right? You can do like insert. Else, you're gonna say something like, queue is full, sorry, nothing can be added. Okay, so we're here. How should I insert?
Should you start at the end of the array and work your way down? Should you start at the end and work your way down?
You call it push method, right?
No.
Sure.
You mean like start like,
Like a pass?
If this is my, if this
Start at the
is, let's
head
say,
and work your way
let's
back.
play like that. Let's say my queue looks like this. Let's say my queue looks like this. This is my front. F is for front, okay?
okay,
And I want to insert an element. Where should that element go? Here, right?
Yep.
Correct?
See.
So size is in this case 2, for example, and I want to insert 13, right? So where should 13 go? Front is 0, right? Shouldn't it go at position front plus size?
No.
Is that clear? Do you see that?
Like front plus side.
You can say size because
Oh,
it's 2, right?
Yeah.
Yeah.
But
Because you
But
put it at the beginning.
if I had something like this, here is front, here size is 1, right? And front is 1, right? Where should you insert? Here still, right? Correct?
right, yeah,
Is that clear?
yeah,
Yes? So you should always insert a position front plus size. Is that clear?
yes.
Yes? Well,
Would you ever run into a situation where you would end up like that?
yes, why not? As you, that will happen. But first of all, what happens if the queue is empty? If the queue is empty, that doesn't make sense because if I insert at -1 plus 0, it will be at position -1. That's wrong. So I have to check if it's not empty. If it's empty, it's very simple. Just insert the element and that will be your front. That's it. Right? So what do I do? If it's empty, what do you do? Simple, you can just put your front to 0, right? Because you're about to insert now, right? And then you set Q at position front plus side, which is 0 plus 0, right? Equal n. And then you're gonna make your size 1 more, right? Done? Perfect? Wanna see problems now? Make your life more complicated, right? Something's always wrong. Good. So this works good. I mean, let's say the queue is empty. So if the queue is empty, then I'll put my front to 0, right? Correct? And then at position 0 plus 0, which is position 0, put n. N increment size. Size now is 1 and front is 0, which is fine because that's the position where it is, right?
Is there a case that front could somehow, in the example board, get
Before
the
getting
four?
getting there. That's fine. That's fine. I can do like that. Okay. So if we have that, seems to work perfectly, right? If we have something like this, front is 1, size is 1, right? And somebody tells me NQ say 9, then it says it's empty, no, so front does not change, right? And then you're saying Q at position front plus size, 1 plus 1 is 2, put the element. So position 2 of there, right? And then increment size to 2. So this guy is now 2. So far, so good, right? Yes, Albert.
Wouldn't it be because once size gets too high, then you won't be able to put any more?
That's the problem. Just to make your life simpler for now. Let's say I have something like this. Okay, what is size now?
4.
If I use that logic, and somebody tells me insert 17, can I insert 17?
You can't, but it's,
I have one spot empty, man. My size is 4, my capacity is 5, so I should be able to insert. Look, it says, if your size is less than your capacity, you can insert.
Right, but you'd be adding a.
So, 17 should go here,
right.
right? So the stack will look something like,
Like a circular.
and this is what they call circular array. Doesn't really matter, those are just names. So, I have to insert it here, right? How do I know that I have to insert it here? If I just go by the logic that is there, I would do this. Q at front plus size is 1 plus 4, right? This is 5, right? Insert 17. Do I have position 5? Array out of business. Boom, crash, tears, and everything, right? What do I do now?
Just check if the front plus size minus 1 is equal to the capacity.
What you can do is check if front plus size is already greater or equal to the capacity, then there is something wrong there. Then what you might have to do is say, if front plus size is bigger than capacity, then the position to insert is at position front plus size minus capacity, right?
Yeah,
You understand what I'm saying?
yeah.
Front plus size is 5 minus capacity 5 is 0, so that's what I have to insert. That's one way of doing it, right? So say if front plus size, so before doing this insertion blindly, right? You could do something like this, right? So before doing this, I could be very careful and do something like this. Pause to insert, right? I can call it even like that. Pause to insert, right? Right? And here I can say if pause to insert is greater or equal to capacity. Actually equal only, but let's leave it like that. Right? Then I have to go around, right? How do I go around? Then pause to insert should become pause to insert would become this same line minus capacity, right? Correct?
Right.
And here I will put pause to insert. Right? Got it?
Do you just need deals
No, I don't need anything else because if this is not true, I will just insert it at unit and post to insert, which is front plus capacity.
Then you need minus
Right.
1,
Sorry?
you need minus 1 as well?
Why?
To get to 0?
No,
5 minus 4, you're at 1, and then minus 1?
no, capacity is 5.
Okay, I thought you said then minus 1 to get into 0. Okay.
No, front plus size is 5. Capacity is 5. This is
Okay.
the index, capacity is
Okay.
5, right?
Thank you.
Got it?
Yeah.
Okay. So this is clear, right? Yeah.
And since after this, let's say we do the circular array, go back to 0, and it's still okay leaving it to increment size, so that X plus the size would now be,
Size will now be what?
5.
5. So you won't be able to insert because size is no less than capacity.
Okay.
You will be safe. Now, if you DQ, now your front will be here. Right? Maybe you inserted, you said 17, right? And then you DQ. This could be your Q also at one point, right? You understand what I'm saying?
Yeah.
This is your front. It has to go like that, right?
Yeah.
Got it? Front equal 2, for example, in this case, size equal 4, right? Got it? The next element should be inserted here, right? Correct?
Yeah.
How do I get that position? Front plus size is 2 plus 4 is 6 minus capacity 5, 1. Got it? So our formula works, right? Let's say it with all of you guys. Yes? There is a simpler way to do this. You just do this. Because then you get to say it's too hard. If you say front plus size, and you make mod capacity blindly, you will get the right position.
Front plus size divided by what capacity?
Mod, not divided, mod, remainder. Remember, if a number, you say for example 5, remainder 8, if the number is smaller than the other guy, then the remainder is himself. Remember? So you get 5. So that means that if you're inside the indexes, you will get the same number. That's correct. But if you're going overboard, you get the remainder, which is what was missed to get there. That would be the position from the beginning. So if it's 6, remainder, capacity 5, what's the remainder? 1. That's the position to insert. If it's 5, remainder 5 is 0. That's the position where you have to insert.
So you can just do it without the figures.
And then you save all the trouble. I'll leave this commented, okay? I'll show you that. I'll put that away as final.
What is this in the last subject? Like no more subjects after that.
Got it? Yes? Clear, right? Now we're done with the NQ. We're covered for all cases. We are able to go round. Now, public void DQ.